All right, today we're going to be going over 2.1, which is the idea of limits. There's a couple of terms you want to be familiar with. So the average velocity is basically the change in speed over a period of time. So it may not predict the exact speed or exact velocity an object is moving, but it's giving you an average over time. Instantaneous velocity is your speed at a specific point in time, and so the text is just trying to compare the two and show you the differences. So the reading will be good here. Over here you get an image, okay, showing you about what we're doing, and so the formula here should remind you of slope. Okay, you have two y values and you have two x values, and you're going to find the difference in those and divide it. And so you have several images and several examples that you can use to refer to. You may not be familiar with secant line, but if not, the secant line is just a line joining 2 points. So it's just basically a line, but specifically telling you there's 2 points on the graph that this point, that this line goes through, 2 points on the graph. And again, to find the slope of the secant line, you just use the slope formula or average velocity formula. They're about the same. And so when you see this, this is how we start to describe limit. So as the t value, so this is what it's saying, as the t value gets closer to another value, so one x value is getting closer to a second x value, the y value is also approaching a point. That point is called the limit, or the instantaneous velocity. Okay. And again, it just looks like the slope formula. We're finding the distance between two y values, dividing the distance between two x values, and getting a slope. And then when we introduce the limit, the way that this is read is we're saying that the instantaneous velocity is equal to the limit as t approaches some other x value. So t is our time in this case, but it could be x. As x approaches some number of the given function, that's basically the slope of that line. So that's how we're going to start out finding limits. So tangent line is another term. It is just a line that touches a graph at one point. Okay, they're just showing you one point where secant was 2 points, and as t or x approaches some specific value, the secant line approaches the tangent line, and the slope of the secant line is approaching the slope of the tangent line. So those two things are happening at once as we're moving. And then here are some illustrations showing you average velocity and secant line, and how to compute those. And so we're going to slowly just inch our way toward an actual definition of limits, but this is where we're going to start. So we're going to jump over to MyMathLab, but what we want to see is that as we get closer and closer to this point, the y value is also getting closer and closer to some number, and we're going to just continue to look at the relationship and talk about what it means to be close, and we'll start defining all of that as we get deeper in chapter 2. But for right now, just remember the slope formula. Make sure you understand what a secant line is, tangent line, and just how to find the slope. Alright, so with that, we're going to jump over to the homework section and start doing some problems.